Now we're solving exponential equations. That's where our variable is in the exponent. A couple different ways we're going to go about doing these. I've set aside 3. Okay. Let's go up here. Great. Now we know we can use the property a to the x equals a to the y. That implies that x is equal to y. Okay, let's do that. Let's try to get the same base. The same base. This is 2 to the x. Can I rewrite 64 as a power of 2? Oh, this is 2 to the, wait for it, is it 6? 2 to the 6th. Yes! So now that I have the same base and they're equal, I can set their exponents equal. X is equal to 6. Very nice. A box. And a second flower. Come on down here. Yeah, buddy. I want to attempt to use exponents to get these guys to the same base. So then, this is 2 squared to the x. Okay. And that is 2 to the minus 1/2, because that is a rational exponent, and then the negative property. So then here I see 2 to the 2x is equal to 2 to the minus 1/2. And then that gets us, since we have the same base and they're equal, their exponents are equal. This is 2x is equal to minus 1/2. And then we find that x is equal to minus 1/4. And of course you should check it on up here. Here, I can't write them to the same base entirely. So what I want to do is I want to use the appropriate logarithm. Yeah, here we are using the base log base b of x is x. So we need the appropriate base. We want our bases to match so that we can get our x out of our exponent. So now I'm here, man. So I'm going to use log base 10. In slang notation, this is log. When I don't have a base there, it's a 10 of 10x is log of 3.91. Because what you do onto one side, you must also do onto the other. Here, log base 10 of 10, using that guy, that gonna be x. And then on the right, this is log 3.91. Sure. And then how do you finish that? You push the button. Do that on your own time. Otherwise, you'll be pushing my buttons. Yeah. Down here. Oh no! I see I can still use that logarithm property, but I need to isolate my base. Okay. So then I divide each side by 5, divide this side by 5, divide that side by 5, and then I'm going to have e to the x is 5. Now I need to use the appropriate logarithm. I need to go login. Yes. Which log do I want to use on the left? Yes. I want to use log natural, the natural logarithm. And then what you do on the one side, you must also do onto the other. Okay, because natural log is log base e. Here you're going to get x. And then on the right, you have the natural logarithm of 5. I prefer you leave it like that, but you can also push that button. A box. And a flower. Now I'm cruising on up here. I see I can't get them to the same base, so I need to use my logarithms. I need to use several different properties of these logarithms. Yes, I need to use the property that we used in the last one. Yeah, and also I need to use this property, log base b of x to the r is equal to r log base b of x. Very nice. That means I can bring that exponent down front. So now I'm over here. Let me use log base 2 of x, log base 2 of 2 to the x plus 1, that's going to be equal to log base 2 of 5 to the x. Okay, check out what I did. I used the same log base 2 on both sides. I went login. I went log base 2 of this side and log base 2 of that side. Now I'm using that previously mentioned property. Okay, so then log base 2 of 2, O to the exponent is going to spit out the exponent. And then over there, I'm going to bring that x down front. This is x log base 2 of 5. Okay, so now I got x's on both sides. Want them on one side. Which side? Don't care. Left-siders. X minus log base 2 of 5. That's going to be equal to a minus 1. Fun. Factor that x out, and you're left with 1 minus log base 2 of 5. That's going to equal a minus 1. And yes. Divide both sides by that 1 minus log base 2 of 5. So then x is equal to minus 1 over 1 minus log base 2 of 5. Yes! And then now you could get a decimal equivalent of that logarithm, but I like exact answers. Bonus round. Yes! Extra innings. Take a look at this one. Sick! Yeah. I'm gonna go and oh no. Yes. I'm gonna try to say that this is quadratic and here's why. Here we have 3x squared. Okay, power raised to a power I multiply. Here I know if I have a to the x times a to the 1. If I have the same base and I'm multiplying, what do I do to their exponents? Yeah, that's right, Adam. That one was for you. So is this one. Then this is the same as 3 to the first times 3 to the x minus 4. Sure, that's going to be equal to nothing. So then if you could dodge a wrench, then you can dodge a ball. Here we'll make a u sum. We'll let u equal 3 to the x. So then I have u squared plus 3 times u minus 4 is nothing. Can you factor that? You're looking for the factors of 4 that subtract to be 3. Are there any? Yes. You gotta get that. You gotta get that 4 and 1. U and U. The signs are different and the big one's positive and that's negative and it's still all good. Now, we want to solve each one of those. U is going to be equal to a minus 4 or U is going to be equal to 1. Fun. I want to take and I want to back substitute that sucker right on up in there. So then this is going to be 3, not E, but 3 to the x is equal to minus 4. Sure. Or 3 to the x is equal to 1. Fun. Now use the examples from the previous talk, well, the regular round, not this bonus round, to finish him. You finish. Ha ha ha. Provide your own box and your own flower. Try undefined in 0.